responsible, isn't it? Yes. Control of the halt signal down there is here. It returns to red either after 30 seconds, because there's a timer on it,
yep,
or when the train passes a treadle.
Right.
So that's that. This is the controls for the other signals. Select the platform you want, select the signal you want. All those are on time, 30-second timer, except for number 5, which is on a 10-second timer, because it's just a shunting loop. Yeah. And then we've got the mimic diagram, which shows the position of the points. Operating the lever will give us that road 5 instead, where the levers are set just at the moment. We're a little bit smug about this because we've got an interlock with the actual point itself. So if the point does not go fully over, it won't set the road on the mimic diagram. And I mean, if it's a millimetre, half a millimetre, not across, it's because we get so much stuff falling off the trees.
Yeah, there's a lot of leaf
so the signalman has to be sure that they know that the road is in fact set, and the mimic diagram gives them confirmation of that. They were set for point 2. The readout from the mimic diagram is coded and then used to display the digits on the end of the console.
Ah, right, that's indicated to drive, right.
Well, so that the people at the turntable know which platform the train will be arriving at.
Yeah.
Or departing from.
So your point detection to prove which way to set, those are opto-isolators?
In the point, yes. There's a buried in the, with the pneumatic cylinder that drives the points.
Gotcha.
There's also alongside it an optical box which I built with a brass slider in it.
Right.
And the brass slider has notches in it.
And you've got a line up.
And 2 optical paths.
Right, yeah.
I thought this was going to be a very risky thing to do because the environment here, particularly in November, is very poor.
Yeah.
The humidity is sky high. We get immense amount of rain.
It's Britain.
You know, it's not the ideal thing for electronics.
Yeah.
So I was quite nervous about it. So it's a belt and braces job as far as we can go. And you know, ever since we put it in, we've had no bother whatever with it.
It works.
Which is superb.
That's a cracking idea.
Yeah. So I can show you the circuit for that down the way there, because
we've
got some spare circuits.
Yeah.
Well, I can show you a made-up circuit.
Yeah.
Because I made a few spares. The signalling system itself and the point system works on flip-flops. Are you familiar with the idea of flip-flops?
Roughly, yes.
It's a bit like an electronic seesaw.
Yes.
And you pull one end down and the other end goes
up.
And then you pull that end down and the other end goes up. When I select platform 2, we'll have a look at the gantry signal in it up there.
Oh yeah.
When we select platform 2, and I press the proceed button, what that does is it sends a negative pulse to the one side of the flip-flop, which flips it down and selects the green signal. After 30 seconds, or when I press the stop signal, then the negative pulse will go to the other side and pull the flip-flop the other way.
Right.
And that's how it works. The points are the same. One of the members built these point levers, which I think are super.
I'm going to say it does the job. Everything's made in house, yeah.
Oh yeah, everything. Yeah. Well, we didn't buy the electronic. We didn't make the electronic components, but everything.
And it's totally waterproof.
To
a certain degree,
fairly waterproof. Yes. Yeah, fairly waterproof. So this is operated by reed switches. There's just a magnet on the end of this lever and 2 reed switches. And of course, the trouble with reed switches is they come in varying qualities.
Yeah.
And we couldn't afford to have ones that were not 100% reliable. So the ones we used are burglar alarm ones. Yeah. And they're not only reasonably weatherproof, but they're also built to a very high standard.
Yeah, and you can get spares.
And you can get spares, no problem. So when you move the point over, what you've done is you've activated the other reed switch and sent a pulse to the point flip-flop. Yeah. Which has moved the point, which has worked the pneumatic solenoids. There's a compressor in here, of course, and that moves the point across. And then the point having moved across, the optical system sends the information back to the mimic diagram.
Yeah.
Well, the mimic diagram's got a series of relays, changeover relays,
Yeah.
which mimic the points.
So just set the route up, yeah.
Okay. So, in other words, if you've got it set to there and you move point 3, the point's moving, but it's not telling you anything on the mimic diagram.
Yeah.
Because the route to the point 3 is not set. That makes sense?
Yeah.
Point 2 not figuring. If I do that, you see, there's road 3 set.
So again, just made in-house LEDs?
No, we didn't make the LEDs, but yes, the whole thing's made in-house. Yeah. It was quite a thing to do when we did it, because it dates back to about 2017.
Oh, blimey. Fair age.
And bright LEDs were absolutely new at that time.
Yeah.
So we had to get a few of those and experiment with them to make sure we ran them at the right current, so that they were visible in bright sunlight.
Yeah.
But on the other hand, not going to overheat or
I'm going to say, because you're lucky it's under the canopy at this point, isn't it?
Yeah, but in the late afternoon, the shadow will be over there and shining more or less
straight into it.
Platform 1's our short platform, and when the train comes in with the locomotive at the front, of course, it pulls well forward, but the carriages mustn't go onto the crossover there.
Yeah.
So, in other words, the carriages will stop about here. Now, when the locomotive does its shunt, round the head shunt, and down and back onto here, if he hasn't parked the train far enough up, there is a danger that the locomotive sits partly on the point.
Yeah.
Now the difficulty with that, of course, is if he then sets off, the locomotive sets off down there.
Carriages go the other way.
Well, he'll have come in that way, yeah, so that the point is set in that, or set somewhere like this, even. Pushed half across. I can't do it. Pushed half across. And then the carriage is around. So there is an interlock with the signal, where there's an optical unit in here, and an interlock with the signal on the console. So you can't select a green if the point is not fully over.
Yeah.
So that's another little feature. I'll just find the optical board for you. Okay. Surely that one will be somewhere. I could go and get my. That's a relay flip flop,
right?
Which we can use for the points, but we can also use an electronic flip flop as well. That's the flip flop circuit, and then these are the transistors that actually do the work.
Yeah. Just made in house.
Oh yeah. And we seem to have a lot of those.
So that's a newer generation with a few LEDs for display for yourself.
Oh yes, that's right. To demonstrate what the board's doing. So that if you take the back off the console, if you've got something that's causing trouble,
you can see what's doing.
Whether the flip flop's working. There's another relay switch flip flop. That's a lighting cluster.
From the signals.
Yeah.
So you can just change them over if they go as well.
If they go, yeah.
Do you tend to get a lot of failures of LEDs, or? No. That's good.
No. The ones on the console, on those big numbers, have been failing a bit, but that's because of the really adverse climate.
Yeah, yeah.
They tend to track across the back.
Yeah.
Short. Oh no, here's the optical unit. You see.
Oh right.
And the slider goes across there.
Yeah.
And operates these relays.
So does it have to prove both or just one?
No, this one will operate when the point is one way, and this one will operate when the point is the other way.
Right.
And then the appropriate one of these relays will switch and send the signal down the data line to the console to work the relay.
Yeah.
You see.
Clever use.
Yeah. The other thing about it, the other little feature is the general voltage that we operate at in the console is 12 volts DC.
Yeah.
But we've got long cables, some of them ancient,
and you lose
and who knows what's going to arrive at the other end.
Yeah.
So what we do is we drop down the 12 volts down to 5 volts here.
Yeah.
And then we use the 5 volts for this, which gives it a stable operating situation. You know. Yeah. So that's it. What we have, I think. Anything else? Oh, this is a monostable. With the treadle on the halt signal. Okay, you've got a train going over the treadle there. You've got every set of wheels works the treadle. Yes. So you get this great stream of negative pulses coming up to the console. Well, the electronics are inclined to get a bit confused. Yeah. So we have the monostable, you see, and the monostable, it just has a timer built in. And when the first pulse arrives, it flicks the monostable, and it stays flicked. Yeah, until it doesn't see a stream of pulses. 30 seconds or something like that while the train passes. Ah, right, yeah. Yeah, and then it resets, so the treadle will again trigger. That's clever. So we have to put that on the driver to the... I don't think we've got one with a timer. No, we haven't. Yeah. That's a very clever use of electronics. The timer electronics fits here, but it looks as though we've used all the ones with timer. So, anyway. That's a clever idea. Anyway, it's all. Yeah. Interestingly, when you make the, because we do CAD. Yeah. When you make the mask for the to make the printed circuits, you've got the position of all these LEDs on the mask. So you can then use another layer off the printed circuit, off the CAD program. Yeah. To do a drilling template for the front of the signal. Is there a reason for just elevating them off the board? Yes, because, well... I usually have one in my pocket, but I haven't got a pocket today. Yeah, the reason for doing that is because this sits on spacers. Right. And they come... back from the front. And also because when we make it, we drive these things... They use 5mm holes. Yeah. And the LEDs are slightly tapered. Ah, so they sit into the holes, right. So you push them as hard as you can into the hole. Yeah. To give us watertight seal as possible, you think. So, clever. Anyway, so that's what we've got anyway. That's just another relay flip flop, but without but with different coloured repeats of the diodes. But it doesn't matter what colour the diodes are. You can see whether they're switching or not. You know, we make the printed circuit board look like that. That's one for a power circuit. So you, again, I'm very loose on the process of it, but to turn this into a printed circuit board. Yes. Next start of the process, then you produce this in CAD. Yes. Then you put this onto a doped material. Yes. You buy these days you can buy the printed circuit board material. True. Yeah. Copper laminate, ready coated with what they call resistance. Yeah. You need an ultraviolet light. And that exposes... so you put that on the ultraviolet light, put the printed circuit board on top. Yeah. And expose it for about 5 minutes. It's 5 minutes, right, it's a long time, yeah. And then that goes to one side. The board goes in developer. Yeah. Which is just weak caustic soda. So it just removes that area? It removes the bit that's been exposed to the light. Right, yes. You see. And leaves the coat on the part that's not been exposed to the light. Right, yes. And then, of course, develop it in something like ferric chloride to etch away what's been there. So the parts of the dark here, they'll be the parts that are protected. That will come out of copper, yes. And that's where the ultraviolet will shine through and just... Yeah. Right. And I mean, in this one here, what have we got here? This one, I think. Because we were making a lot of these, there are 4 on a sheet. Yeah. So just make them as a sheet that size and then chop them up with hacksaw. And that's the one for the signals, of course. Yeah. Because it would also allow... And once again, we make 2 signal clusters on one board. So are these fairly stable now you've printed them, or do you have to keep repeating every 5 years, make some new ones? Well, since I made this is 1917, I think. Nothing's been done. Blimey. So, I mean, I put them in this folder for the club because of the explanation about the signalling system, and. When I'm long gone, if somebody else needs to make some more boards, and you've got them there. Well, in theory, anyway. The console. And the reason for doing these was to identify which board did which thing. Yes. The idea of the modular approach is that if you have a fault, it's only one fault.
Yeah.
Whereas if you put them all on one printed circuit board, which we could have done, and one goes wrong.
Yeah, you've got to change a lot.
You've got a lot to check then, you see. And these are the pneumatics. These are the point flip flops, as you can see. Those are all electronic point flip flops. Sorry, I'm messing you out.
No. That's quite good. So.
And this shows the solenoids, the pneumatic supply. There's a manifold here which picks up the
so that's the main
main air coming in, fed to each of the solenoids in turn, and then distributed out to one side of the.
So you've got colours in blue and red as well.
Yes, that's right. Yeah. Frank's the specialist on pneumatics.
We had a member, Ken, who actually made it. It's fairly realistic.
I'm going to say it looks quite good. Very lightweight, nice and tiny. I have a demonstration one when I do and all it is plastic rings, not brass rings, but it looks the same as that. Yeah. So that's just for Santas only.
Yeah. Well, it's if anything goes wrong with the
main
signals
system
down the middle, we've got to have a backup, haven't we?
That's your backup.
So this, as you know, is a backup. We also, in case if the electricity fails, there's a complete outage.
Yeah.
Then obviously the pneumatics are not going to work when the air runs out. So we also have locking pins on the points.
Yes.
So that if
manually lock them.
Yeah, so that you can push them over and lock them for the passengers to go through.
It's a clever idea.
So if you like, that's the basic. When all fails, back to the handle
use that
stuff. Yeah.
So that's not interlocked into any machinery. It's just the visible
that's
staff.
For show. It was just as I say, the guy who did it, Ken. He was he was one of four of us, my wife and myself and Ken and Chris. We used to go on the mainline tours, steam tours. And he's one of those guys, you'd fall asleep and when you wake up he'd tell you exactly where he was. God knows how he does it, but he was really, really, really into it. And he just did that for the Santas, which was a bit fun. So we've got the Bromborough box diagram, of course, which that is genuinely taken from the 1946 arrangement, which it's fading a little bit now, which is a shame. And of course, it's now or nearly all gone. So
yeah,
they've done away with the old shed now. But that was there. I had the original of that.